So the one other thing we've got to do in 2.7 is the rational inequalities. And remember, with rational inequalities, that basically just means we're talking about fractions again. And the setup on it's going to be basically the same thing as what we're doing with the polynomial inequalities. You're still going to find those boundary points that set this thing apart as you're going through this one. The only difference is that when you're doing one like this, just give you an example of what it looks like here. You have something kind of like this, where you've got x minus 4 over x plus 3, and that's going to be greater than or equal to 0. Or, sorry, just greater than 0. You'll still do the same thing on this part. You're going to take to find the boundary points. You're going to set the numerator equal to 0 and the denominator equal to 0. And just like with the part before with the polynomials, you'll still take one value, plug it in that's anywhere in that boundary area, see if it makes it true or false. Go through and do the same thing. So the only difference on this one is that you're just going to do numerator equal to 0, denominator equal to 0, and that'll be your two boundary points. So for this one, pretty straightforward. It's x minus 4 equal to 0 and x plus 3 equal to 0. So that's x equals 4 and x equals negative 3. Okay, so just start plugging in numbers and see what happens. Anything to the left of negative 3, if you'll plug in negative 4, see what happens. That's going to be negative 4 minus 4 over negative 4 plus 3. And the question is that greater than 0? So that's negative 8 over negative 1 greater than 0. That's 8 greater than 0, so that part would be true. So when we plug in negative 4, we get a true statement. And again, because that one was just greater, you'll use parentheses on this one. Shade everything in this area shaded. Parentheses, the same thing as open circle. Okay. And again, it should alternate, but just to be on the safe side, we'll go back in and plug in a point in the middle in here. And again, to me, the easy one right here would be to plug in x equals 0. So you've got 0, 0. Getting minus 4 and then plus 3. And again, the question mark is that greater than 0? 0's knock it out, so it's just negative 4 over 3. That's negative. It doesn't matter what it is, negative 1.3, whatever you want to make it there. And that'd be false. So that part we won't shade in. And then one more time. Again, this one should be true, but just check it just to make sure, because sometimes it does some weird things. Plug in the 5. Do a minus 4 and a plus 3. That's 1 over 8. Greater than 0, that's definitely positive, so that part would be true. Okay, so Still the same thing. Still go back through and plug in the numbers to see what you get. And for the most part, it alternates. Now, again, depending on if you get it a little more complex of a problem, it doesn't always necessarily have to alternate, but most of the time, kind of generally speaking, it does. All right, let me get you one more of those. Everybody good? Everybody still copying? Because this is the one that's got one little trick to it. So we'll go 4 minus 2x over 3x plus 4, and that's going to be less than or equal to 0. Okay. And again, to get the boundary points, we're going to take the denominator and the numerator, both of those equal to 0. So for this one, we'll get rid of the 4. Divide by the negative 2, so that means x would equal 2. This one will subtract 4. And then divide by the 3. So it's negative 4/3. And again, if you're looking at number-wise, it's about 1.3. Okay, and if that one's a decimal, doesn't really make a difference because when we plug in the test points, you still plug in a whole number just to make it easy on you. Okay, so this is negative 1.3, and that's 2. Okay, now here's the one little detail that you have to get. This came out of the numerator. And as far as the numerator goes, this one you can have it equal to 0, so it's going to be okay. You get to use a bracket. You get to use the square bracket. Anytime you do the denominator, doesn't matter if it's got the less than, equal to, greater than, equal to, or if it's just less than or greater than. Anytime you use something out of the denominator, it's always going to use parentheses. Because it goes back to the domain question that you cannot have anything in the denominator equal to 0 because it makes it undefined. So for that one, no matter what this sign is here, when you're working through this inequality, the denominator will always use parentheses. The top part, it's going to depend, the numerator part of it, boundary point, that one will depend on whether it's going to be greater than or equal to or less than or equal to, or just a straight greater or less than like this one was. This one you'll use parentheses every time. For a problem like this where you've got the less than or equal to, the top part you'll use the square bracket, but the bottom part you're always going to use a parentheses no matter what. And that's the one little thing that's, it can sneak up on you when you're not paying attention because you're just kind of used to the habit of putting square brackets when you see that symbol. So for this one, you know, that's just the one little detail. That's the one detail you've got to be careful about when you're doing these problems. Okay, so let's pick a number somewhere off down here. It's negative 1.3. Again, I'd say just maybe negative 2. That's the next number popping up there. So plugging in negative 2. It's 4 minus 2 times negative 2 over 3 times negative 2 plus 4. And again, the question is that less than or equal to 0? Okay, top part, that is 4. Negative 2 times negative 2 is a positive 4. On the bottom, that's negative 6 plus 4. So that's 8 over negative 2, which is negative 4. And is negative 4 less than 0? Yes. So we'll get to shade in everything on that far left region. Okay, and now we were using negative 1.3. Here's where we're going to be careful. So this was the negative 1.3 that came out of the denominator. So for this one, you have to use parentheses. When we get to the 2, that's the one we get to use a square bracket on. So you're going to kind of have to go 50-50 here. All right. Again, 0 is in the middle, so plug that one in and see what happens. Put the 0 here and the 0 here. That's 4 minus 2 times 0. 3 times 0 plus 4. So that's 4 over 4. So it's 1 less than 0. That's a no, so we get to skip that value. Okay. And again, pick one more point over here just to make sure. But it looks like we're going to have to bracket this in and shade it in, but just double check it to make sure. Plug it in 3. 4 minus 2 times 3 over 3 times 3 plus 4. We've got 4 minus 6 over 9 plus 4. Negative 2 over 13. And again, it doesn't really matter what the number is. As long as it's negative, it's going to be less than 0. So negative 2/13 is less than 0. So that one would be true. So that would be yes back. Okay, so the basics are still the same as what we're doing with the polynomials. Still find the boundary points. It's just top part and bottom part, numerator, denominator equal to 0. Get your boundary points. And again, the only catch to this one at all is that regardless of what the sign is, if whatever number comes out of the denominator for your boundary point, that one will always use a parentheses. This one, coming out of the numerator, depends on what sign you use. Less than or greater than is parentheses, but if you use a less than equal to or greater than equal to, then it's definitely going to be a bracket with that.